part 2 of statistics. Let's talk about hypothesis testing. What is hypothesis? A hypothesis is an assumption that, for sake of argument, we make and we want to be tested. So two of the most known and used hypotheses are alternative hypothesis H1 or HA, or null hypothesis H0. So an example of alternative hypothesis is a male salary is higher than a female salary for a same job position. So for alternative hypothesis, we have two variables and they are related to each other, and it's not by chance. And this is alternative hypothesis, and the null hypothesis is something that is trying to nullify alternative hypothesis. So example of null hypothesis for the same example, it's going to be a male salary is equal to a female salary for a same job position. And what we have here is like we have two variables and we are trying to say they are not related to each other, and there is no difference between samples, and the effect that they have on each other is just like by chance. So what we're going to do is like we try to nullify H1, and we try to either reject null hypothesis or we fail to reject null hypothesis. And if we reject null hypothesis, we can accept the alternative hypothesis. There are some other hypotheses as well: non-directional, directional, and statistical. The non-directional, it says there is a relationship between two variables, and but it has no direction, which means we do not recognize the which variable A is affecting B or B is affecting A. For the directional, we know there is a relation, and for example, we know A is impacting B. And for statistical, it's like a hypothesis that can be verified to be plausible using statistics. The hypothesis testing can be divided in parametric test and non-parametric test. And parametric test, it can be divided into regression, comparison, and correlation. And for the regression, we have simple linear regression, multiple linear regression, logistic regression. For comparison, we have t-test, Anova test, and Anova test. And for correlation, we have Pearson R, which we have talked about this before. In the next slides, we are going to talk about t-test, Anova test. And for non-parametric test, we have Spearsman, chi-square, Wilcoxon, sign test, and many more. For the parametric one, we have a clear assumption about the population, and the population of data has a normal distribution. We have lots of information about the population and parameter, and we know the median, the central tendency, and it's very clear, something like interval and ratio variables like age, height, weight, temperature. And for the non-parametric one, we have no assumption. It's like very unknown distribution. We don't know the type of distribution. It's not like this one that we know it's a normal distribution. And we don't have any information about the population. And the central tendency value for these is median as well. And nominal data, something like race or educational level, these kind of data can be used for non-parametric one. So when we do hypothesis testing, there are 4 steps to test a sample. a hypothesis. First, we are going to state the null hypothesis and alternative hypothesis. And from the beginning, we assume the null hypothesis is going to be true. So we assume this is going to be true, and we try to reject this null hypothesis or fail to reject that, right? And we are going to randomly select a smaller set of samples from the population, and then we are going to, based on the information that is given to us, like the type of variables that we have, number of samples that we have, and many more factors, we select the test and we execute that statistical test. And then we make conclusion about either rejecting null hypothesis or fail to reject null hypothesis. And when we reject null hypothesis, then we can accept the alternative one. But it's not something that we work around alternative hypothesis. We work around the null hypothesis. An example of these 4 steps is going to be we state the hypothesis, the null hypothesis here. We are going to say men on average not getting a higher salary than women. And the alternative hypothesis says the opposite one. It says men are on average getting higher salary than women. And we collect the test samples. We collect equal proportion of men and women in different industries, in a scope of one country, let's say the United States. Then based on the type of data that we have, we are going to select one tail t-test. And then after running the test, we conclude that the average difference is 20K, and the p-value that we get is going to be 0.002, and we are going to reject null hypothesis. And you might sound like, what am I talking about? What is p-value? And so on. We are going to briefly talk about them later. So let's see what significance level or confidence level means, and what p-value is. The significance level or confidence level, which is indicated by alpha, is a threshold that we use to decide whether a test is the result from a test is statistically significant or not. And it helps us to decide if the relationship between the variables is caused by chance or there is a strong relationship between them. And alpha is, as I said, for the parametric test, that is the t-test and Anova test, and this is what we are going to talk about. We are going to have normal distribution, and the alpha lays in the area inside the tail. These corners of the normal distributions are called tail. So we have 2 tail or 1 tail, and the way that we do that, we are going to say 1 minus the confidence level that we want. Let's say we want to have 95%. We need to be 95% confident. So 1 minus 95%, it's going to be 0.05. These are the common practice alpha that we use: 0.01, 0.05, and 0.1, which is going to be 99%, 95%, and 90%. And the p-value is the probability value that we calculate this, and I'm going to tell you how to calculate that. And we are going to compare this with the level of confidence, the confidence level or significance level that we want. And if the p-value which determines the plausibility of a null hypothesis, which we can decide either reject or not reject that. If the p-value, which always has a value between 0 and 1, if it is bigger than alpha, so it says the results are not statistically significant. So let's say the alpha lies here. So this is the alpha that we have, and the p-value stays here, right? This is the p-value. So the p-value is going to be bigger than or equal to alpha, and then we are going to say we fail to reject null hypothesis. So null hypothesis is not going to be rejected. But if the p-value like lays down here, so we are going to say we are going to the p-value is smaller than the p-value is going to be smaller than alpha, and we are going to reject null hypothesis, right? And there are some errors that can happen. So one of them is the type 1 error, which is when the null hypothesis is true, but we have rejected that by mistake. So this is the type 1 error. And the type 2 error is when the null hypothesis is false, but we failed to reject that. So this is the type 2 error, which can happen. And I have got this pictures and this from here. And now let's talk about z-test. So what we can do with z-test is, as I said, we are going to have a normal distribution for parametric testing. And the normal distribution formula is this. To calculate a percentile, a data point, we should standardize a normal distribution to standard normal distribution. What is a standard normal distribution? It's a distribution that has a mean 0 and the variance, the standard deviation of 1. So the way that we can calculate that, what we are going to do, we need to standardize the value of the normal distribution and calculate the z-score by population mean and population standard deviation. As you see here, this is the normal distribution, the mean is 1010, and then we standardize it, and it's going to be 0, and as you see, we have the standard deviation of 1. So if we have a single data point, this is how we calculate z-score. If we have independent and distributed samples, this is how we are calculating z-score. And if we are talking about proportion, this is how we calculate z-point. And then after calculating the z-point, we look at the table and map the z-score to the area under a normal distribution curve, and we return the p-value. Then we compare the p-value, and if it is bigger than alpha, as you see here, we fail to reject null hypothesis, and if it is if the p-value is smaller than alpha, we reject the null hypothesis. This is the z table that you can find it in this website as well. So based on the z, that like the way that we read this table is like, let's say we have z value 3, let's say 0.05. And for finding the p-value for this z-score, we find this one, minus 3.0, and then we find the 5 one here. So this is the p-value that we have, right? And for this is for the from 0 to minus 3.4, and this is from 0 to plus 3.4. And let's now talk about student t-test. The student t-test is used to see if two groups of data are different from each other, and we don't know the standard deviation of the population. So when we don't know that, we use t-test. The assumption is still we have a normal distribution, the similar variance for each group or sample that we have, and we have same number of data points, which is smaller than 30. And if it is more than 30, we use z-test. And the null hypothesis says there is no difference between groups, and the alternative hypothesis, it says there is a difference between groups. There are three different types of t-test: one sample, dependent or pair sample, independent two sample. The one sample is the test if a population mean is equal to some value mu, and this is the formula that we use to calculate t-value, and this is the degree of freedom. And for the dependent is test whether two population mean are equal by sampling the same population twice, and this is the t-value formula, and this is the formula for independent two sample, and this is how we calculate degree of freedom. And then we check it on this table based on the degree of freedom and based on one tail or two tail and the significance level that we need. After calculating the t-value and df, we determine about the one tail or two tail and the level of confidence that we want, and then we look up the critical value from this table. And if the critical value is smaller, if the t-value is smaller than critical value, we are going to not rejecting null hypothesis, and if it is bigger than critical value, we are going to reject the null hypothesis. Here you can see the t-test and z-test are used to determine and compare the significance of data set of data. And if the standard deviation is known or not known, we go through different paths. If we know the standard deviation of the population based on the sample size, if it is smaller than 30, if it is bigger than 30, and if is the population is skewed, is not skewed, is a normal distribution, we are going to use t-test. And if it is skewed, we are going to use sign test. And if we have bigger than the sample size is bigger than 30, and if it is not skewed, if it is a normal distribution, we are going to z-test, and if it is skewed, we are going to use alternative methods. And if we don't know the population sigma, like standard deviation, we are going to use t-test if it is not skewed, and if it is skewed, we are going to use alternative methods. As I mentioned here, this t-test is for when we do not know the standard deviation of the population. As you see here, when we don't know standard deviation of population, we use t-test. But when we know it, we use z-test, and especially when it's bigger than 30. There is another test called Anova Test, which determines the effect of several categorical independent variables on one numerical independent variable. We have one-way ANOVA, two-way ANOVA, and n-way ANOVA. And the t-test is designed only for two groups, and for more than two samples, we should use ANOVA, and which uses a variance to measure how far the data are scattered. So this is how we calculate ANOVA. We calculate the variance between groups and within groups. Then we calculate the degree of freedom. Then we calculate the F value, which is going to be the variance between groups divided by variance within groups. And after calculating that, we get a critical value or F score, which can be selected from this table. There is an F table as well to get the F score. from the F value for the degree of freedom of the between groups and degree of freedom within groups and the selected alpha, and then we can compare the F value and F score, and if it is F value is bigger than a critical one, we are going to reject it, otherwise we fail to reject it. This is a very good table that I got from this blog by Maureen. So these are different test statistics: z-score, t, f, and chi-score. And the associated test is going to be z-test, t-test, and the Anova test is going to use for f-test and the chi-score. It says this one is good for 2 population or large, and 2 small samples, and 3 and more. And as you see, it shows here, so when we have a standard deviation of population, we use z-score, and when we have a standard deviation of sample, we use t-test, and when we have the group size and mean and a standard deviation, and we have 3 or more samples, we use Anova. And these are all good for normal distribution, and the chi-square is good for any kind of distribution. The question that we are going to answer for z-score is going to be, are these 2 populations different? And then it's going to be for the samples, because it's going to be smaller than 30. And do of any of these 3 or more samples differ from each other? And are these 2 categorical variables independent for chi-square? This is another chart that I got from Angelica from towards data science, and you can see that like you can find the parametric and non-parametric test. As you see, it depends on like how many samples we have, how many variables we have, if we have the population standard deviation, or if we don't, we are going to use different tests. And for the non-parametric test, we are going to say based on the number of samples we have, we can use Wilcoxon, we can Ron's test, and Mann-Whitney, chi-square, and many more. This is another fellow chart from Scriber. This is going to be a very good way to decide what type of test to use. And Python has, like, for all the calculation that you see above, Python has library which is a SciPy library that we can use to get the like Gaussian or normal distribution, find the linear relationship between the Pearson R, and also we can do the experiment. Like it has library and module for almost all of the tests. And what we can get the z-score, we can do the t-test, we can do the Anova test, we can do the Mann-Whitney test, and it's going to be very easy to do that. And then based on the value and probability that we get, we can decide to reject the null hypothesis or fail to reject the null hypothesis. Thank you.